Okay, so we have a flatbed truck that is slowly tilting its bed upward to dispose of a 95-kilogram crate. And it says that this crate doesn't start moving down the bed of the truck until we hit 23.3 degrees. So we need to find out what the coefficient of static friction is. And that coefficient is telling us essentially how much force we need for this to start moving. And then it tells us that if the coefficient of kinetic friction is 0.4, what is the acceleration? So when the crate starts moving, how much is this kinetic friction affecting its ability to move? So let's go ahead and start by drawing a force diagram for this. I'm going to do it in a more detailed version and then move on to a simplified. So if we have the bed of our truck, the crate on top of it, the very first force we can always draw is our weight. I'm going to write this as mg, mass times gravity, because that's always what our weight is going to equal. Another force we always know is the normal force. Whenever an object is resting on a surface, or even moving on a surface, there's always a normal force pushing up against that surface, which we're going to write as the force normal. And in this case, we also have the force of friction, which is holding either the block in place or affecting its speed. So now I'm going to draw this as a simplified diagram with a point diagram here. So once again, we have weight going down, and I'm going to try to keep our force angles here pretty stable. And notice that the normal force and the friction force are at a 90-degree angle. That isn't always necessarily the case for the weight, however. But normal and friction will always be in a 90-degree angle. Okay, and something else I'm going to do right now is actually draw so our angle here, the 23-degree angle, is going down here. Let me draw it better on this one. So our angle is here. That is the 23.3 degree angle. We can do the decomposition of that angle into cosine on our x-axis, and then I'm going to do it up here, sine of theta on our y-axis. So now we have all of the information that we need to start working on these problems. So the first one, what is the coefficient of our static friction? So the way that we can think about this is the force that's acting on the block when it's not moving at all, and the force that's acting on the block at the instant that it starts moving should be equal due to the conservation of all of our energies. So at exactly that 23.3 degrees, the forces acting on the block when it's not moving equals the force acting on the block when it is moving. How can we write that? Well, the force acting on the block when it's not moving yet is simply the weight, which is mg, and then the part of the normal force that is directly opposite our weight. So if you notice here on the normal force, it's not all pointing in the same direction as our weight, as in the y-axis or the x-axis. And with forces, they only help or cancel each other out when they're facing the same direction. So mg times sine of theta is the force that's acting when it's not moving. And that should be equal to the force acting on the block the instant it starts moving. So that's going to be mg cosine theta times our coefficient of friction. Because at that point it has started moving, so there is friction acting on it. So if we notice, mg cancels on both sides. So if we kind of rearrange some things, we get our coefficient of friction is equal to sine theta over cosine theta, which is simply equal to tangent of theta. This is actually something super helpful to memorize, this little equation here. This comes up a lot when you have something when you want to calculate your coefficient of static friction. This is going to be the most common way that you see it coming up. So that gives us our coefficient is equal to tangent of 23.3 degrees. Something with this, also make sure your calculators are in degrees, because otherwise you'll get a different answer. And that gives us 0.43. And that is our coefficient of static friction. Okay, so now it tells us, assume that your coefficient of kinetic friction is 0.4. What is your acceleration going to be? So let's look at this by considering the forces that are acting on the object when it's moving. So imagine a block sliding down a ramp. You have the force that's pushing it to the right or down the ramp, and you also have the force of friction pushing against that movement, so pushing to the left or up the ramp. So we can say that the forces acting on the block are equal to the force that's pushing it down the ramp, so it's weight times sine theta, and then subtracting any force of friction that's acting against that movement. So that's going to be our coefficient of friction times mg cosine theta. Okay, so now let's look at what we want. We want acceleration. Well, if we remember back to our force equation, the fundamental force equation is force equals mass times acceleration, and that's what we're looking for. Well, if you notice, all of our terms here share mass. So if we divide our entire equation by mass, we're going to get force over mass, which is equivalent to acceleration. So let's go ahead and rewrite this equation solving for acceleration now. So acceleration is going to equal g sine theta minus our coefficient g cosine theta. And now we can go ahead and plug in all our terms. You can factor out g if you want, it's the same for both. I'm just going to go ahead and leave it in. So we're going to get 9.8 sine of 23.3, and our coefficient was given as 0.4 times 9.8 times cosine 23.3. And calculating all this gives us an acceleration of 0.276, and the units here are going to be meters per second squared. And going back to the previous problem, coefficients of friction, static, or kinetic don't have any units. So there we go, and that's the solution to this problem.